All right, so I was asking a question to balance a reaction in acidic conditions. So what we talked about in class is that you split everything into a half reaction. You're gonna balance the oxygens with water, balance the water with H+, then balance electrons. Then you have to balance each individual half reaction to make sure they have the same number of electrons, and then you add them back together. All right, so let's go ahead and start, that was a lot of words. Let's start by just breaking them into the half reactions. So here, this guy's going to there, that's oxidized. It went up in charge, and here the nitrogen was reduced. It went down in charge if you calculate it out. And in fact, why don't we? So over here, we have a total of -1, and we know that we have 3 oxygens, so 3 times -2. So over here, the nitrogen must be +5. And over here, we know that our total is 0. We know that we have 2 times -2 for the oxygen, and so nitrogen must have been +4. So it went from +5 to +4. I just wanted to show you that it was in fact reduced. So we take the oxidized and the reduced, and we break them down into half reactions. So here we have copper solid broken down into Cu2+. All right, on these, when there's no oxygen, it's pretty straightforward. You can just balance with the total number of electrons. So over here, I have a total charge of 0. Over here, I have 2 positive. In order to cancel out that 2 positive, I must add 2 negatives. In other words, 2 electrons, because now 2 positive plus 2 negative equals 0. And this half reaction is balanced. Then we move to the next one, where we have NO3 negative, getting NO2 with no charge. Note there's no charge written, so we don't write a charge. All right, but in this case, we want to immediately go to electrons, but we have to recognize that this stuff has oxygen in it. When there's oxygen in it, you have to follow the rules that we talked about. So we're gonna balance it in acidic condition. I know we went through those rules fast, but let's break down and go through each one. All right, step number 1 is we're gonna balance the O with water. So for every oxygen that we're unbalanced, we're gonna add a water. So over here we have 3 oxygens, and over here we only have 2. So we need to add 1 more oxygen to it. So we add that H2O. Okay. So I'm gonna try to separate this. All right, so step number 1, we balance with water. Step number 2, we're gonna balance the water with H+. Okay, so over here we added a water. In other words, we added 2 hydrogens. So our next step is we have to add 2 H+s to the other side to balance it out. Cool. Okay, so that was number 2. Number 3. Once we add the H+, the beautiful thing is because it's in acidic conditions, we don't have to do any OH-, which is what we would do next for basic conditions. So we can just move on to balance with electrons. All right, so my total charge over here, I have 2 positive plus 1 negative for a total of 1 positive. And over here, I have 0. So I have a +1 and a 0. So I have to add 1 more negative to this side in order for both sides to be equal to 0. So I'm going to add 1 electron. Plus this nitrate. Plus the 2H+. Sorry, I kind of moved them around. Still the same reaction. NO2. Plus H2O. All right. Last but not least, we want to add them up together. So 4. Add together, but in order to add them together, we have to multiply the whole thing times 2. Over here, and the reason we're doing times 2 is because over here I have 1 electron, and over here I have 2 electrons. You need them to be equal. So in order to do that, we're going to have to multiply them by 2, this one by 2. You never know, you can multiply this one or that one or both of them by something in order to get the same number of electrons. But thankfully this one came out pretty straightforward, so we're just going to multiply it by the whole thing by 2. So now we have 2 electrons plus 2 NO3 plus 4 H plus, yielding 2 NO2 plus 2 H2O. All right, now we have our 2 electrons. And now to that, we can add this Cu solid, Cu2 plus 2 electrons. So we got 2 and 2 on each side. Those two are going to cancel out. And when we go to add them up, I have a copper plus 2 nitrates plus 4 H pluses to 2 NO2 plus 2 H2O plus Cu 2 plus. Cool. All right, and last but not least, we look to see if there's anything to cancel. I don't have waters on both sides, so I'm okay. I don't really have anything to cancel. But you do want to see if the electrons on both sides add up to be the same thing. So for example, over here, I have a total of 2 negative plus 4 positive for a total of 2 positive. And over here, I also have a total of 2 positive. So this going to that works. I have the same charge on both sides, and that is my final balanced reaction for acidic conditions. All right, I hope that helps. See?